Welcome everyone. In this video, I'm going to continue from the earlier one and show you an example of using the linear method on a set of results to get from the raw data to a final equation that makes the connection between the x's and y's that we found from our data from our experiment. Okay, reminder, we have to have the parent graphs, parent functions, slope equations, and such ready to go. So let's begin. We did some experiment and got these results. Not only the x like we saw in the earlier video, but we got some y values as well. So what you need to do is you need to create a good looking graph of these data points in order to see what the shape is. Now by design, I've created them so that they are the quadratic, or they come from a quadratic function that they create a shape that looks like this. So recalling all the parent functions that we have, this is a parabola. And as we saw, this is related to, or as we know even, this is related to x squared. So the next step is to update the x values so that they match the relationship we have here, so that they use the parent function that we see. Okay, so the update from x is going to be to x squared. So that means we're going to have x squared values in here. Where do they come from? The original x's. So we got minus 2 squared plus 4. Minus 1 squared plus 1. 0 squared, 0. 1 squared, 1. And 2 squared, 4. Now hopefully that was nice. We had a look at this in the other video. What we now have to deal with are the y values. And this is nice because they stay the same. No change. So this 4 came from that negative 2, so that's the 20. That 1 is with the 5. 0 with the 0, 5 with the 20, or that's a lie, 1 with the 5, let's do it that way, and 4 with the 20. Now this part's new. What you have to do is create a graph with all of these values here. So the updated x values, these are along the x-axis, and the y values are, well, along the y. So just to show you, I'm not going to do the whole graph because it goes all the way up to 20. But just to show you the x values, we have a goes from 4. We got a 4 over there. We got a 1. We got a 0. All right, so I guess I could put a couple of points on. 0, 0 for sure. That's nice. So that can go there. And actually, maybe what we could do is this. We'll make that 20. Put that up at the top. 20 right there. And what is that value? When x is 4. Looks like x squared, which is my concern, but treat it as an x value. So when x is 4, we got a y value of 20. So that takes care of that one. Give it a little check mark there to show that you thought about it. We have a value of 1 and 5. So we got 1. If you split this in half, that's a 10. I'm not going to write it down. It's getting a little crunchy. Split it in half again, and it's a 5. So that's where the other point goes. That one there. We can look at the other ones, but I think, of course, you can see that they are just repeats of what is already there. So, laying a ruler down, using a nice set of eyeballs. The question was designed so that this should be a straight line going there. If it isn't, if this line, after all your good hard work, is not a straight line, then you have to go back and do this part again, or maybe even this. You got to check and see that you chose the correct parent function and that the numbers were proper from the experiment. All right? But we're looking for a line. If we get one, then we can continue. And what do we continue with? Continue with this. You find the slope of the line that is there using, as I said, have it nearby, slope formula. And if you recall from the graphing session, it said use numbers that are easy and also far apart. So I think 0, 0 and 4 and 20 count for that. So what's the slope going to be then? It's going to be 20 minus 0 and 4 minus 0, which gives a slope equal to 5. Well, we're almost there. Because now what we can do is connect a couple of pieces that we saw earlier, or that are here in front of us. One of them is that y depends on x squared. And the second one is that the slope is 5. So here's how the final equation looks, how you set it up. It's always going to be the y value. It's going to be multiplied by the slope that you find when it's a line. And then it's going to be multiplied by the updated x, or the parent function. Okay, so the updated x, or the parent function. Well, what do we know? We know our slope is 5. This is the number that makes these numbers work together. If we get this number wrong, then it doesn't work. But the slope gave it to us from some careful arithmetic, careful drawing. Number's 5 there. All right, what do we have here? The parent function. Okay, it's not x. That's our original result. But we use the updated x. So now what we have is x squared, because it matches what we had in the very beginning. And so, full circle almost. What have we done? We were given original data and a challenge. Find the equation that matches these numbers together. The equation that matches these together. You first sketch it out, create a graph. You identify the graph and the parent function that goes along with it. To see if you're correct, to make sure, you update the x values that we had in the beginning with that parent function and create a new set of data points, a new table. Graph these things, not being confused that that's a squared thing or something. Just treat it as old regular x in the new graph. You create the picture, and you hope that it's a line. You draw it carefully. when you see that it is, life's good, and you continue moving forward. To do what? Continue moving forward to find the slope of this line that you have here in front of you. Choosing results that are easy to read and far away. I chose those ones. And then you get the value for the slope, which is the magic number that does the connections between the parent function and the y value. The slope that makes is the number that makes the equation work. So you put the slope in, you put the parent function in that you saw way back in the beginning, and you celebrate the result that you get. After all, that's hard work. So that concludes this video. What I recommend is the following. These are easy to rewind, not like the old days. So give it a stop. Rewind it back to the to this point here where you see the original data. Put your papers to the side and just try it again. And you can just sketch it out. If you want to be serious about it, you can do it all again, professional style, or just sketch it out and go, oh yeah, I do this, then I do that, then I do this. Yeah, quick, just to make sure that you've got the process down. And maybe do it a couple times, just like you're rehearsing a song or something like that. And when it's comfortable, when you see where all the bits and pieces are and it's snap easy like your favorite tune, then conclude this video and go on to the next example where I work through this process with one of the other functions, which will be for you to find out. See you next time.